A little loud. Welcome back. I hope everyone was invigorated from lunch. This afternoon, I'm pleased to welcome for this next discussion, Mr. David Bernstein from Space System Loral. Space System Loral is a local company and a worldwide leader in construction of spacecraft. And David is the Senior Vice President for Program Management for SSL. So, welcome to the stage, Mr. Bernstein.
Thank you, Dan. Good afternoon. So I'm going to be talking some about affordable space programs. Probably not quite as affordable as you were hearing at lunch, where it's kind of down in the millions of dollars a piece. We're still talking numbers in the single-digit hundreds of millions, 1 to 2 type million, maybe 3, and applying the commercial model that we at Loral have been using for a number of years. One of the things that Dan didn't mention is we're premier leader in space, but it's commercial space programs is what we're normally doing, typically commercial communication satellites. So I thought I'd start by talking about where things are today and where things are in the commercial space program. It's kind of an interesting week because Monday marked 50 years since Telstar, the original Telstar, went up. And that's kind of the start of the commercial space program, commercial space communications. And you can probably tell from my gray hair, I'm actually old enough that I remember when that went up. And it was very interesting because it wasn't geosynchronous. It was a low Earth orbiting satellite. It moved around. And I remember watching the news. There's Walter Cronkite sitting at his desk, and there's a TV screen in the corner behind him. And he's talking about what's going to happen, and they're waiting and waiting and waiting. And finally, you start to see static on the screen, and it clears. And there's the image coming from Europe. And you hear voice and video coming from Europe. They were able to communicate back and forth for maybe 10 minutes. And then the satellite went out of view of the United States. And that was the end of that. It went back to static, and that was the end of it, and that was the whole thing. But having said that, it was a pretty exciting and pretty important thing because this was kind of the start of commercial space communication. All it was at that time was voice and video. Now, since then, voice has kind of faded away. Telephones all go terrestrial. The terrestrial people filled in the gap. Satellites don't carry that much voice now, and there are other things that are carried on satellites. So, if you look at this spacecraft was roughly that big, maybe approaching a meter in diameter. It's roughly spherical. It turns out they built 6 of them, launched 3, and I've actually seen one of the ones that's still on the ground. So it's pretty interesting when you compare it to what's out there today. So this is a spacecraft, commercial communication spacecraft. It's at launch base now. It's slated to launch next week. It's about 7 meters tall and about 3 meters by 3 meters on the rest of it. So quite a bit bigger, quite a bit more capability. It's going to stay in one place. When you start talking through it, you can talk as long as you want or run data as long as you want through it. And now, instead of just doing voice and video, we're doing things like broadcast. The things you guys all know, direct TV type things, dish network type of communications, the normal fixed satellite services, which is, when you see ground-based antennas pointed at the sky, those are all doing fixed satellite services, kind of private network type communications. Mobile services, of course. Digital radio, which you guys all probably know is Sirius XM. And then finally, the big emerging marketplace is just broadband access. And everybody who's sitting in a place like where we are now is saying, broadband access, why do I want to use a satellite? And you're right, if you can get to wireless or you can get to some kind of cable system or a fiber optic system, there's really no need for that. But there are a large number of people who are in rural areas and can't get high-speed access to the internet, and satellites coming on big to provide that sort of service. So these are the kinds of things that are being done with commercial satellites today. So if you look at that range over the last 50 years, a number of things have developed in the commercial satellite industry that have helped us learn how to be cost-effective and time-effective in producing our products. And what's driven all of this is really our customers. And as a satellite manufacturer, I kind of look at my customer as the satellite operator who buys the satellite from me. But he also has a customer, and his customer is the end user. And the end user is really the person who's driving this whole thing. And what the end users want is very large amount of capacity, very large amount of capability, and they want that to be absolutely assured. So by capacity, what we mean is bandwidth, which of course in radio stuff is what everything's all about. And assured communications, probably the best example is to talk about what's going to start this evening and go on for the next 2 weeks, which is the Olympics. And how do the Olympics relate to space? It's all coming out of London. Every TV station in the entire world is going to be there, and they're going to be sending their signals out through the satellites up to whatever country they're going to, and then relaying it out to the viewers. And that means whether they're going over a broadcast satellite like DirecTV or the Dish Network, or even the people on cable, the cable head ends are all being fed by satellites, or even if it's direct over the air, because the station over the air is still being fed by satellite. So the satellites are providing all that connectivity. You're busy sitting there watching your favorite sport, whatever it happens to be, and it better work. And that's what the end user demand is, and that's what the end users are all pushing back to the people who provide the services. So it kind of starts there, and we're not going. There we go. And the satellite operators are the ones who provide that service basically to the people who provide the information to the end users. They're demanding high reliability, and they're demanding a lot of capacity, and they're kind of getting pulled on both ends. So they want me to provide as much capacity as I possibly can, because that's how they make money. And oh, by the way, since they're going to make money on the other end, they don't want to spend a lot of money. They're cheap. And so they're kind of pushing everybody on both ends. So they want very high capacity, maximum capacity for the buck that they spend. And that's what's driving the commercial communication satellite industry. So what does that mean we need to do? We need to look at on the reliability side, we do a number of things. And one of the things that the commercial industry has done is they've gone and standardized a lot of stuff that they do. We've standardized our operations, and you standardize your processes. Now, everybody standardizes processes. That's no big deal, because if you do a different process every time, you know things might not work. But the thing that's happened on the commercial side as opposed to the government side is we have a tendency to run every single program we do, every spacecraft we build, with the same set of operational processes. And what we strive to do is work with the operators and say, here's what we know works. We've done it repeatedly. If you ask us to change it, we can change it, but there's always some risk. If we do the same thing, we know this is going to work. And we know we can do it quickly, and we know we can do it cost effectively for you. So that's kind of become very prevalent in the industry now, something that the commercial folks do to keep reliability up and costs down. We also depend on proven designs. The greatest fun is you walk into a new potential customer who says, I need a new satellite, and it's got to do this and this and this and this. And remember the last one you built for me? Well, I want all that stuff, plus I want all this other stuff. And you say, okay, great, here's what we can do. Oh, wait. It's got to be stuff you've flown before, which becomes an interesting conundrum for us, because the operators all want proven technology. They all want something that's flown in space, and they've seen it operate again and again, and they have assurance on it. And yet they also want us to keep improving. So how do you do that in an effective way? What we've learned how to do is do developments well ahead of actually starting a program, so that when the program starts, we've actually completed development. We've completed all the work to qualify the program. We may have even taken a scaled back version and flown it as an experiment on a previous spacecraft. Or we may fly it as this corner of the spacecraft will use the new stuff, the rest of it will use all the old stuff to prove it out. And then we can go forward and do it. And we've done this on a number of cases in the commercial industry. Probably the most notable one being the transition in power systems from the nickel hydrogen battery technology to the lithium ion battery technology. And the commercial communication satellite providers were the first ones to do that a number of years ahead of when the government finally caught up with that. And all of that's been working fine. It's about 7 or 8 years on orbit now. And there have been absolutely no problems, because the industry has learned how to bring all that forward to provide the reliability that's needed. Excuse me. And then the final way we keep up reliability is by having volume in the business. And what does that do for you? What it does is it keeps the supply chain vital. You heard at lunchtime, one of the problems was the supply chain's not going to be able to provide what they need for their flights to the asteroid. What we need to do is keep the supply chain vital, keep the supply chain operating, keep the supply chain moving so that they're constantly putting out product and reliable product. The other thing that that does for us is it allows us to see a lot of product coming through our facility. And as we do that, instead of just seeing 1 or 2 items where there may be something wrong buried in here, but you're only going to see it 1 out of 10 times. Well, if you're only building 1 or 2, you'll never see it. If you're building 20 or 30, you're likely to see it. And the good news is you catch it. The bad news is every once in a while it happens. And when it happens, it pervades everything that you've got in your factory, and you've got to go work it. But the good news is it's not going up in space, and you're keeping reliability for the end customer and keeping assurance of providing product. Did this flip? Yeah, okay. And then the other half of it is the customers, as I mentioned, want us to maximize capacity for the dollar spent. So maximizing capacity, technology keeps moving forward. Technology is going to allow us to keep maximizing capacity. The trick is to keep the dollar spent down as the technology moves forward. And one of the ways you do that is when you go forward to start a program, you make sure that you're starting on something that's based on the capability you have. Don't go try and do something brand new and start from scratch and decide that everything's got to be new on this spacecraft. Use over what you can use over and find those key places where you want to do something new. Want to put something in that's going to help you push your capacity, and that allows you to keep your costs under control. And the other thing that's really critical to this is how you do the program structure. And if you run it, as we talked about before, from the reliability point of view, if you run every program differently, you're going to have reliability problems. You're also going to have cost problems because you're reinventing everything on every single program. So what the commercial industry has learned how to do is design all their spacecraft similarly with similar components and then run them as an integrated whole so that they've got assembly line type advantages in costs. Now, the customers all push us on schedule, and they all want schedule down, and keeping schedule down also tends to keep costs down because if you have long schedules, you got lots of people hanging around doing something. Who knows what, but they're also charging along the way. And the big concern about all of this is that if we're running on a tight schedule, that at the end of the day, you're going to decide, I'm going to cut corners. And this is what we hear from the government side all the time. How do you keep it under control? And the commercial side has figured out how to deal with this. They have incentives for us having spacecraft that work properly. And what they've basically incentivized us on is, first of all, delivering on schedule. And the way that works is it's actually a disincentive. If you're late, you're going to pay penalties. So that's going to motivate us to go faster, and the risk is that we're going to cut corners. But what they've also done is said, oh, by the way, if it doesn't work on orbit, you're going to lose money. And depending on the contract, some of them we have to pay back money, some of them we don't get on-orbit incentive payments. So we're incentivized from that point of view to do it. Now, those numbers are there. We pay attention to them. In the big scheme of things, they're actually relatively modest when compared to the big club that's out there. And the big club that's out there is what one of, at Loral's, one of our biggest customers is always reminding us of, and that is you're only as good as your last satellite. And what he means by that is if your last satellite was no good, I'm not coming back. And we've seen that happen in the industry repeatedly. And if you're kind of in business for the long haul and your customers stop coming back, you've got a real problem. And that, at the end of the day, is the real incentive. Because the satellite operators, the customers of the satellite manufacturers, are very adept at voting with their feet and letting us know when they're not happy and deciding that they're going to go somewhere else. We've seen it happen that way. We've also acquired a few customers with the help of some of our competitors, because our competitors have made our customers very upset, and we've kind of reached out to them and attracted them. So it kind of cuts both ways if you're a manufacturer, but you kind of work through all of that. And through all those controls, the industry is actually able to keep costs down and keep schedules under control and keep reliability up. So what does all that mean for us? The result of all of this is that right now there are 300 commercial communication satellites in geosynchronous orbit, approximately. I think it's a couple less than that, actually, if you count them all up. Most of them have 15-year lifetime, roughly. A number of them are less than that, but the more recent ones are all designed for 15-year lifetime. If you do the math, that means on average, 20 of them are reaching the end of their life a year. That means replacement business is 20 satellites a year worldwide. And then there's anything new that people are starting to add on, new capabilities that they're adding on. What that also means, it's a fairly robust industry. There's also a huge amount of data that's coming back from space that's telling us how all those spacecraft are operating. And at least in our business, we're constantly monitoring what's happening up there, what's working well, what isn't working well, and then plowing that information back into our designs and our processes to make sure the reliability stays up. So all of this is playing together to keep costs under control. The other thing that's going on is if you look at the industry backlog today, and this is the worldwide backlog for commercial geocommunication satellites. There are 67 of them out there. What's shown here is each of those satellites. You probably can't see it, but the name is there. And then as you go across the top, there are the various manufacturers in the industry. And you'll see that most of those manufacturers have a significant number of satellites in their factory. And typical satellite takes about 2 to 3 years. If you figure 2.5 years on average to build, most of these factories are running about 5 satellites a year through their minimum. And that's about what you need to get this nice steady flow that I was talking about to keep everything nicely under control. So having said all of that, the next big question is, what does this mean for others in terms of bringing costs down? What does this mean for government-type programs? And what this really means is that instead of deciding that every government program is going to make everything brand new, start to separate what you've got. And take a look at finding those things that don't have to change, like the bus, like the communication system. And by the bus, I mean the subsystems that generate power, the subsystems that do propulsion, our attitude control, our data handling, those sorts of things which are pretty standard spacecraft to spacecraft and aren't a whole lot different between one manufacturer and the next and between commercial and government. And also some of the communication systems, which are pretty similar, maybe slightly different frequencies, which really doesn't matter because we're always tweaking the frequencies anyway on the commercial stuff. Build all of those the way commercial people do. Use the same kind of standards, the same kind of procurement system, the same kind of tools to keep the manufacturers in check, and then go take those few exquisite things that you need for your mission, be it military or civil or space exploration, and build those separately. And those are going to cost more, there's no question about it. And they're going to have more risk, there's no question about it. But those are all unique, spacecraft to spacecraft. And when you start to look at marrying those two things together in that way and figuring out how to balance that and couple that type of program together, you can start to look at significantly reducing cost and schedule. And we believe that we're looking at a factor of 2 to 3 on both of those, based on what we've seen. So to kind of sum it all up, over the last 50 years, the commercial satellite communication industry has come up with a large number of ways to keep reliability up and to keep costs under control and schedules under control. And many of those can be used at some level to bring forward into government-type systems to get them some of those same advantages. So I'll take questions. Yes?
You guys are starting to build solar electric spacecraft, all-electric spacecraft. Are the thrusters that you're using, are they suitable for deep space missions? Can you run them for thousands of hours?
Some of them can, some of them can't.
But you do have some.
But there are some. In fact, our company has contracts that are looking at doing just that with NASA, that are looking at, excuse me, solar electric propulsion for deep space type missions. Yes, sir.
Is there not some sort of, because I think NASA has a catalog of its own that it draws from when it's designing stuff. How many different, are there different categories of spacecraft, or how does that work? Are there like different buses for different applications or different sizes, power levels?
There are certainly different sizes. I mean, the spacecraft I showed is a pretty big spacecraft. There are still small spacecraft in that size category, and I think that's one of the big things that one needs to look at and sort through, but definitely yes. Nothing over there. It's only on this side of the room. Over here?
Yeah, could you comment on payload hosting that might support investigations, perhaps somebody's commercial venture that they bring forth?
I'm sorry, could you repeat it? Because I was busy coughing and I couldn't hear.
Yeah, could you
I apologize.
comment on payload hosting, hosted payloads that might support either science investigations or perhaps somebody's commercial venture that they want to bring forward?
So payload hosting is certainly a very cost-effective way to get to space. I mean, there are several pieces of getting to space. There's building whatever it is you want to take there, but then there's all the burden that goes behind it. So there's all the spacecraft stuff that you need to support it, power, propulsion, whatnot, and then there's the launch vehicle. So if you've got something that's relatively modest in size and can share those costs with somebody else, then you can get a much more cost-effective ride to space. So that certainly helps out. Having said that, over the years, we've in fact done a number of hosted payloads for a broad range of applications, and today we're looking at a large number of them because there's always a little bit of extra space somewhere, and provided you get in at the right time, you can make all of that work.
Thank you for being here. My question has to do with the dirty four-letter acronym called ITAR.
Mm-hmm.
As we know, Loral is one of the world leaders in communication satellites, and we've seen what you've talked about, how to reduce costs. By moving commercial satellites from ITAR to the EAR, the Export Administration Regulations, how much of a savings would that be to Loral, and is Loral involved at all helping to get that moved, or commercial communication satellites moved to the EAR? Thank you.
Okay. So let me start with the last part first. Yes, we're interested in seeing the satellites moved, commercial satellites moved from ITAR to EAR. There's no question about that. In terms of how much we'd save, I don't know the number. There certainly would be a savings because I know when we're working with foreign customers, there's a significant cost involved in doing that work, a significant cost involved in a number of things relative to that. And quite frankly, we talk to these foreign customers and we go through all the export control work, and they know all this stuff anyway because they learned it from the French manufacturers. So,
Thank you.
yes, sir.
Loral is probably going to be bought by MDA according to the latest announcement. So you have one of the largest satellite builders being purchased by the single biggest proponent of in-space servicing and especially in-space refueling. Assuming that the purchase goes ahead, would it be unreasonable to assume that in a year or two's time, Loral satellites all might be kitted out with at least scarring for easier in-space refueling and services?
Okay, so
In other words, what's the
Yeah.
culture in Loral? Is there going to be a culture clash between MD and Loral on that subject, or?
Okay. So I mean, the fact is, MDA is going to buy Loral. We're going through all the government regulations and approvals right now. It'll close later this year. In terms of what actually happens when we start working together, we're in a period where we can't have those conversations with MDA at this time because we're not one company yet. And until that happens, we can't have those conversations. So it's not totally clear to me where we're going to end up, and I'm not going to speculate on that. But you're welcome to speculate on what you think might happen.
No, okay, let me rephrase. What is the culture internal to Loral now? What has it been on the subject whenever it's come up, if it's come up, on scarring for in-space servicing and refueling?
So that I can answer. Thank you. We've actually worked on a number of things with certain parts of NASA talking about refueling. We've spoken to some of our current customers about in-orbit refueling. We've looked at what it takes to do it. We have a rough idea of what it takes to do it. On the other hand, we've also looked at the economics, and we can't make the numbers work for commercial satellites. We can see how they could work for government satellites, but we can't see how they work for us. So there may well be something we're missing, and after we have a new owner, we may find out what the magic sauce is that'll help us figure out how to do it. But at this point, we're pretty much neutral on it. If our customers want to do it, we'll figure out how to do it. And if our owner wants us to do it, we'll figure out how to do it too.
That's a great lead up to my question. So there's a lot of different cost models and a lot of different pricing models and theories and tools behind them. Currently, do you all have a preferred model and tool set that you like to use to do all the different cost trade-offs as you take a look at the needs of the customers and then do the costing?
So, as I mentioned, we do a lot of stuff that's reuse and modification. We've got a really good handle on what everything costs. And I know the government has some interesting cost models. What's interesting is when we share data with the government, they look at our numbers and they go, oh my God, you have actuals from 20 programs. And the cost model kind of goes out the door at that point. And that's pretty much what we depend on. And then what's left is a relatively small percentage of the whole that we have to do our estimating on. And even if you're wrong by a factor of 2, the bottom line doesn't change very much. So, I think we got time for one more question. I'm getting signaled that we're close to the end here. So there's one right here.
Somebody else should get it if they want. I've already got it.
Oh, okay.
If nobody wants it, I'll take it.
I think it's yours.
Maybe you can't tell us this, but let's assume you wanted to buy a 25 kilowatt bus from Loral and you're going to put your own payload. How big the check do I have to write for you?
Depends on how big the payload is, and and exactly the details of the payload. But round numbers, commercial spacecraft these days are ranging from maybe 150 million to 300 million.
That's including the communications package.
That's the whole spacecraft.
Right.
And everything we need to do. It doesn't include the launch vehicle.
Right.
The launch vehicle is going to run you another 80 to 100 million.
Okay.
And then there's insurance and the ground station.
But what if you don't need the communications package? You got your own payload that you built.
That becomes something that you really got to sit down and work, and we can actually work it through, but it's certainly less than that number. Okay. And at that point, it depends on what we need to do relative to that. But we can talk after I'm done here. Okay, thank you very much.